Hello students, and now we are going to start our chapter 9, which is applications of integration. Okay, so now we are going to study in detail regarding the formulas in exercise 9.1. Okay, so the first thing that we are going to study is a Riemann integral. Okay, so let us see what is this integral. Okay, so just look at this diagram. So in this diagram, this is the point x naught. Okay, this is the point x naught, and this is the point xn. Okay, okay. So we are taking x naught to be a, and xn to be b. Okay, that means this is the lower limit and this is called as the upper limit. Okay, and this line is the x-axis. Okay, this line is the x-axis. Okay, and we are considering a curve. This rose color, no, pink color curve is the function f of x. Okay, so it is the curve for the function f of x. Okay, Riemann integral is used to find the area. Okay, area under this curve. Okay, or else between this curve f of x and the x-axis. Okay, so this integration is all about to find the area of particular particular thing, or else in other words we can say that between two curves, or between three curves. Okay, so in integration is all about to find the area. Okay, area. Okay, so here we are going to find the area between the x-axis and the curve f of x. Okay, and the limit of x is a to b. Okay, a is the lower limit, b is the upper limit. Okay, here how they are doing is they are just splitting the interval a to b in equal number of intervals. Okay, in equal number of intervals. Okay, that means x1, x2, etc., xn minus 1. Okay, and the length between each interval is always equal. Okay, keep that in mind. Okay, so in this way they are taking. Okay, so we have three formulas. The first formula is left end rule. Okay, this formula goes like this: integral a to b f of x dx. Okay, so dx means the limit a to b is the limit of x. Okay, so whatever variable you are having here, if you are having dy means the limit is with respect to y. Okay, the lower limit of y is a, lower limit of y is b, but here we are having dx. Okay, so dx means the limit of x is a and the upper limit is b. Okay, so in this way we have to consider. So we are finding the area between f of x and the x-axis Okay, so if you that is denoted by integral a to b f of x dx. Okay, the formula is limit n tends to infinity and maximum of xi minus 1 tends to 0. Here this xi minus 1 is the length of the subinterval. Okay, the length of the interval. Okay, that is xi minus 1. Okay, so that the maximum is towards 0. That means very lesser value. Okay, you have to make it too short. Okay, in that way we are taking that interval. Okay, so first one is n is tending to 0, and maximum of that interval should be 0. It is not should be 0, it is tending to 0. That means closer value, closely they are taking the interval. Okay, so this is the limit, and summation I is equal to 1 to n. Okay, here 1 to n f of xi minus 1 into xi minus 1. So this is the major part of this formula. So this integration can be equal to summation of f of xi minus 1 into xi minus 1. So this is the length of the subinterval. Okay, so here I takes the value from 1 to n. Okay, and here f of xi minus 1. So this is called as the left end rule. Okay, now we are going to see the right end rule. Right end rule, which is very similar to the left end rule. The only difference is here you are writing xi minus 1, but here in the right hand rule you are taking xi. Okay, xi. Okay, so that is the main difference between the left hand rule and the right hand rule, and all the remaining are same. Okay, and the next thing is midpoint rule, the final one, midpoint rule. So in that midpoint rule, the only difference is this part. Okay, f of and here what you will do now, f of xi minus 1 plus xi divided by 2. Okay, so this is all about the three formulas for the Riemann integral. So the first one is left hand rule, the second one is right hand rule, and the third one is midpoint rule. So you make note of these three changes. Okay, so these are the formulas that we should know to do the exercise 9.1. Okay, clear? Thank you.